Hi, good morning. Did you ever feel your phone vibrating in your pocket, took it out, and there was actually nothing on it? Yeah? Yeah, all right. So this is actually something quite interesting called phantom vibrations. And 9 out of 10 people already felt that. It's basically when you imagine your phone vibrating, but actually it never did. But there's another word for this. Can you guess what it is? A hallucination. I mean, personally, I'm actually quite scared of this because when you think about it, we've gotten so conditioned by technology today that with just a smartphone and a computer, we're already imagining things that don't exist. So when you take into consideration what's happening in the next 10 years, with all of those connected devices that are going to be flowing over us, what's going to happen? What's going to happen when every light bulb and every chair and every table is trying to compete for your attention? Like, we're going to start building coping mechanisms, and there is no way that we're not going to become slaves ourselves. So, there is a solution to this, right? And the solution is actually artificial intelligence. Because when you think about it, the reason why it's so hard to use technology today is because as a human, you need to make the effort to learn how to use a machine. So every time you want to use a new machine, you need to learn how that machine works. And so the cognitive effort that's required to use more technology increases with more technology. But if you start using artificial intelligence to make those devices able to understand you better, able to communicate with you in natural language, then you don't have to learn how to use them anymore, right? You don't have to care about how your TV or coffee machine works. You can just ask it what you want in the same way that you didn't have to learn how to talk to me because we share language together. And if you can start putting AI in every one of those devices, then perhaps you can rethink the way you're interacting with them. And artificial intelligence has been growing pretty fast. I mean, I think, the whole reason we're talking about this today, and I was just lucky that my field got super hot, by the way. It's not due to some new groundbreaking algorithm, right? Deep learning has been around for many years. It's actually due to the convergence of two factors. The first one is almost infinite and free computing power that anybody could use. When I was doing my PhD 10 years ago, we didn't have cloud computing, right? We had like a cluster of computers at university, and it was so hard to make anything work on 400 nodes. Today, I could probably do that on my laptop in a few minutes. The second thing is the amount of data available for training those AIs. So basically, think about it this way. There is an exponential increase in the amount of available computing power, an exponential increase in the amount of data available, and so the two together are compounding and creating this really crazy speed at which artificial intelligence is being adopted. So you can imagine a point in the future where the capabilities of artificial intelligence will far outweigh whatever problems and whatever machines are trying to do. And at that point, what I believe is that the perception of connected devices is that they're going to be completely disappeared. It'll become like electricity, right? Electricity is something so intuitive to use that nobody got into that room thinking, oh my God, there's electricity everywhere. Nobody cares because you forgot about it. And if machines around us are able to talk to us like we talk to humans, you're not going to think about it anymore. It's going to disappear from your consciousness. So what do we mean when we talk about AI? Maybe this is a bit more technical, so you guys might know. Can someone give me a definition of AI? You look like you would know. Yes, well, what is artificial intelligence?
Kind of intelligence managed by they try to simulate themselves.
So, see, that's the difficult thing, right? Is everybody's talking about AI, but we don't even have a definition. So that way I like to think about it is that artificial intelligence is about reproducing human behavior in a machine, right? And in artificial intelligence, there are many different techniques that exist to do that. One of them, which is very popular, is called machine learning. The idea of machine learning is that instead of programming a computer to do something, you're giving it examples of the behavior you want it to learn, and it will learn by itself to reproduce it. This is very important because what it means is that you no longer need to have a human expert understand what you're trying to automate. You can just collect data about what you're trying to automate and feed it to the machine. So we're moving away from programming computers to teaching computers to do things. And because it's so much easier to actually get data about something than code a machine, you're also having a lot more automation at a much faster speed. And within machine learning, there is a specific type of algorithm family called deep learning. The idea of deep learning is really not complicated. You've got this very loosely based on brains kind of network of neurons. So each of those dots is, think of it like an artificial neuron, which is really just a fancy word for saying like a number. And those different neurons are connected to each other, and they're going to be passing information to each other. And what happens is that when you give it, like, let's say, pictures of a cat, each pixels of the cat is going to represent one neuron in the first layer. And by looking at many, many different pictures and combining them together, it's going to start learning the concept of an edge. So it's going to see that, like, very often in those pictures, there's something called an edge. And now that it knows the concept of an edge, it can combine those to produce like an abstract representation of what a cat is, and therefore it can predict when it sees a cat that this is a cat. So the idea is really quite simple. What's amazing though about it is that at no point the human has described what the cat was. Traditionally, when you did machine learning before deep learning, you would actually have to program first, well, you know, I'm going to look at the contours, and then a cat has fur and pointy ears. So you would have to describe what a cat is for the machine to recognize it. You no longer have to do that. You just feed it the image, and it'll figure out by itself how to recognize it. This is what we're using for self-driving cars. This is what we're using for, you know, medical imaging. This is what we're using also to do things like style transfer. This is actually quite interesting. You can learn to reproduce the style of a picture. So let's say in this case, Van Gogh paintings, and apply it to another picture. So you take a, well, actually this is a good picture, but you could take like a really terrible picture and it would turn it into a Van Gogh painting. So, you know, you can already do these things. This is actually quite old technology, by the way. Some more interesting things recently, you can also start generating stuff. So for example, here, this algorithm is taking a sketch that you do by hand. So let's say you're drawing something, and it will create a high resolution rendering of what you're drawing. So think about the implication for architecture, for design, for fashion, when anybody now can start designing things just by drawing on a piece of paper instead of having to learn all of those different tools. It's also what has been used to be the world champion at Go. Go was an important landmark because people thought it would take another 10 years. The difference with chess is that chess you could beat just by brute forcing, so just calculating a lot of combination. But the game of Go has so many combinations that the only way to win was to actually play the game. And the way they did this is quite interesting. They took a machine learning algorithm, so one of those neural networks, and it made it play against the other neural network. And they played for like billions and billions of games, exchanging feedback every time they were playing a move, something called reinforcement learning. And by doing that, they basically learn how to play the game. So imagine if you and I just played a billion games of Go, teaching each other and giving us feedback after every move. I mean, we would get good after some point. At the time they did this, the world champion, I think, won 2 out of 5 games. Today, nobody can beat the machine anymore because the machine kept on improving over time. It's getting better and better. It's becoming superhuman at that point. But there is something we're still kind of not really good at, which is language. The reason is because language is very complicated for a machine to understand. If you're asking your assistant, you just give away an Alexa, which is not a good idea, by the way. If you ask something like weather in London, this is pretty easy because there is nothing ambiguous. You know, you're asking about the weather in London, so anybody can answer that. But let's say you're asking something a bit more interesting. Find me an Italian near my Airbnb in London. Well, the first thing you need to figure out is Italian is a place type, because semantically speaking, this is perfectly correct to go in the street and ask someone, are you Italian? But this is probably not what you meant, right? If your AI just brought back like an Italian person in your house, you'd be a little bit scared about it. But then Airbnb in London makes absolutely no sense to a machine, because this is not a location or a place. This is actually a reference to something that makes sense in your own context. So your Airbnb in London is not my Airbnb in London. And so to understand language, you actually need to start integrating external context into the actual analysis of the sentence. And this is why you need so much data about a specific person. You need to know their emails, their calendar, you need to know their location history, you need to get access to their text messages. The more information you can get about a person, the more data you can get about the context they're in, the more you can disambiguate what they're actually meaning. And so by doing this, you can understand that Airbnb is a location provider because we've got emails from them, that London is mentioned in one of those emails, that the dates corresponds to today, and therefore this is the address you meant. By giving external data, external context to your artificial intelligence, you can actually start disambiguating human language. And this is something which is really hard to do, by the way. The problem, of course, is that we're starting to see this happening everywhere. So we see this in those home assistants. We see this in every single device around you is now having a voice assistant. It's really becoming kind of like the new big thing. Your TV, I love this example, actually, because using your TV is so hard. When you're looking for a program, You have no idea how to find it. You could just talk to your TV and say, put on the soccer match, and it would just work. You know, same thing with your car. I don't know about you, but when it's the winter and I'm cold and I'm driving, I have no idea how to remove like the condensation on the windshield. So I just, you know, pull down the window and I'm cold again. I could just tell my car, you know, take off the thing. But all of these things, all those devices, you have to understand that they're basically listening 24/7. Because by definition, if you want to be able to trigger them just by saying, hey, Alexa, or hey, Siri, or whatever, it means they have to be actively listening all the time. And so, you know, people are starting to ask what's happening to all of that data. You know, what happens when I'm putting all of those devices in my house? Because you might be thinking, well, it doesn't matter, I know when it's triggering, but in fact, all of those home assistant devices, they also trigger about once every couple of hours randomly, right? Because they thought you said Alexa, but maybe you said something else, it just mistriggered. And so at that moment, they're going to record about 10 seconds of conversation that you did not know they were recording. And that is being sent to the cloud for processing, and therefore you've got a lot of issues. Fortunately, in Europe, there is something called a GDPR, which seems to be quite a big topic here. I'm really happy. It's really my kind of place, I think. Most people don't really realize that, but if you've got a Google Home device or an Amazon Alexa in your house, technically speaking, because the voice is processed in the cloud, it should ask for explicit consent to every person whose voice is capturing. So imagine if you've got a dinner at your house and you've got 10 people coming. In theory, if you really applied the law, it should ask all 10 people for consent, which would be an absolutely horrible thing. If you've got an iPhone here and you're saying, hey Siri, it's activating, so it's listening. So, you know, number of people here times number of people here, like you get the idea. This is actually a pretty big problem. But there are ways that you can solve this. Privacy by design is finally becoming a thing, especially in artificial intelligence. And you can do things like processing the data directly on the device. Let's not forget that all of these things are very powerful computers. And it turns out that today, you can actually do deep learning on an actual device. I mean, my company, we've been able to do a voice assistant with deep learning end-to-end on a Raspberry Pi. So it's not even that you need like, you know, super powerful chip, like a very basic $5 hardware is enough now to run the most sophisticated kind of artificial intelligence models you can have. Which really begs the question, if you can do this on a device without sending any data to the cloud, what would be the reason to do it? Maybe you're selling the data, or maybe you don't know how to do it, in which case I'm not sure I would trust you as a company. I'm also quite bullish with everything that's happening with secure computation. I'm actually pretty convinced that hopefully in the next few years, we're going to start having things such as homomorphic encryption in those AI systems. So this is the kind of stuff I'm really looking forward to. And the reason I'm talking about all of this is because, I don't know about you, but since I was a kid, everybody's been telling me the future is going to look something like this, right? So a very oppressive, very dark, gray, with tall metal buildings, advertising everywhere and policing all the time kind of future. But when you actually talk to people, and you ask them, what is the future you want? Well, everybody kind of says that, right? Nobody wants this oppressive future. People want to feel very peaceful, like when they're on holiday. And to me, I really believe this is what artificial intelligence is about. It's about making technology disappear so that we can all feel disconnected all the time. Thank you.